Right, today we're going to be looking at more with special right triangles. We're going to look a little bit deeper, a little bit harder. So what do you know about the two triangles that we're looking at? Explain how you know. When I look at these triangles, I see a right angle, I see a 60, which means this has to be a 30. I see 60, I see 90, I see 30. When I look at the angle measures, I realize that they are similar triangles. And I know that they're similar triangles because we have three congruent corresponding angles, and we don't even need three. We only need two. So we know this by angle-angle similarity. So we think back to our last unit all about similarity, and we know that two figures are similar if their corresponding angles are congruent. And for triangles, we can prove this by having two of the three angles congruent. So because they are similar, we can set up proportions of corresponding sides. So this is the side across from 30, the side across from 30. These are two corresponding sides, so I can set up a proportion 4 root 3 all over 1. And let's pick x is across from 60, and that's going to correspond to 1 root 3. So x over 1 root 3. If I want to solve for x now that I have my proportion set up, I cross multiply. So this is 4 root 3 times 1 root 3 is equal to 1 times x. And we had our radical review, so we know how to multiply our radicals. It's 4 times 1, which is 4. Root 3 times root 3, we can go that long way of saying root 9. And the square root of 9 is just 3. So we find that x is going to be equal to 12. Or remember, we know anything times itself, root 3 times root 3 is just going to be 3. That radical's canceling. Now we want to set up another proportion to solve for y. We're going to use that same way we began before, 4 root 3 over 1. Again, we're looking at these two corresponding sides. Now we look at y. Y is corresponding to 2, so we set that equal to y over 2. We cross multiply, so that's 4 root 3 times 2 is equal to y. Outside numbers together, remember when you're multiplying radicals, it's about location, so we get y equals 8 root 3. So an alternative way to solve special right triangles is to set up similar triangles. If you want to, this is definitely a way to go. When we do it in class and when we do examples, 99% of the time I'm going to show the pattern just because that's the way I like to do it. But know that there's always a way to set it up with similar triangles as well if this is easier for you. All right, so we looked at some basic special right triangles yesterday. We're going to look at some harder ones today. We always start by labeling the pattern. So I've got to identify, is it a 45, 45, 90, or is it a 30, 60, 90? And I see 45, 45, 90, which means the legs of the triangle are s's, the hypotenuse is s root 2. So yesterday the pieces that we were given were either s, or it was really easy to find s. This one is not so straightforward. This time I'm given that s root 2 is equal to 20. Remember, if I'm not given s, my first step is to find s. So to find s, I have to divide by root 2. Anything divided by itself cancels. Now I have a problem. I have a radical on the bottom, and during our radical review, we reminded ourselves that we cannot have a radical on the bottom, so I have to rationalize. So I multiply top and bottom by root 2. That gives us 20 root 2 all over 2. 20 divided by 2 is going to cancel, so we find that s is 10 root 2. So this missing side right here is represented by the s pattern, so this is 10 root 2. This is also s, so this is also 10 root 2. So in this case, x is 10 root 2, and y is 10 root 2. We go into number 2, we've got a 30, 60, 90 triangle, so we've got a different pattern here. Across from 30 is the L, across from 60 is the L root 3, and across from 90 is the 2L. Now that we have our pattern labeled, we look to see what piece we were given. We were given that L root 3 is equal to 30. Since I wasn't given L, my first step is to find L. So since it's L times root 3, we divide by root 3. Anything divided by itself cancels. We have the same problem that we did in the last one. I can't have that radical on the bottom, so I rationalize by multiplying top and bottom by root 3. That gives me L is equal to 30 root 3 all over 3. 30 over 3 can be reduced down to 10 root 3. So this tells me that L is 10 root 3. I look around my triangle. This side is L, so this side is 10 root 3. This side is 2 times L, so this is 2 times 10 root 3. We're multiplying radicals now, so it's numbers in the same location. 2 is outside and 10 is outside. So this becomes 20 root 3. So we see, in this case, x is over here, so x is equal to 10 root 3. Y is 2 times L, so y is 20 root 3. All right, our next one, we've got 30, we've got 90, so we know this has to be 60. Across from 30 is L. Across from 60 is L root 3, and across from 90 is 2L. Always start with labeling where our pieces go. Then we look to see what we are given. In this case, we are given L root 3 is equal to 5 root 2. If I don't have L, the first thing I do is start by solving for L. So we divide by root 3. Those cancel. We have the radical on the bottom again. That's our problem. We need to rationalize. This time when I look at it, I have a 2 inside and I've got a 3 inside. So L is equal to 5 root 6 all over 3. So when I look back over here, this side is L. So this side is 5 root 6 over 3. The hypotenuse is 2 times L. So that's 2 times 5 root 6 all over 3. When I multiply this out, 2 times 5 is going to give us 10 root 6 all over 3. Remember, you may want to try to simplify that 6 over 3, but you can't because 6 is inside the radical and 3 is outside the radical. It's all about your location. Inside numbers together, outside numbers together. So we look and here's our missing side x. X is 5 root 6 over 3. And y is 2 times L, so that gives us 10 root 6 all over 3. All right, we have one more left for our notes today. We've got these joined triangles together, and we are going to look at them separately and together. We have to use them to solve each other, but we want to make sure that we can identify them separate as well. So I'm going to have a triangle over here, and when I look at this triangle, I see that this is 90, this is 60, this is 30. So this is my 30, 60, 90 special rights triangle. Across from 30 is L, across from 60 is L root 3, and across from 90 is 2L. Then on the other side, we have another special rights triangle. This time we have 45, 45, 90. So this is going to be S, S, and S root 2. What you should notice is this side right here. That is a shared side. That is going to be the link between our two triangles. We are going to start with the information, the one piece that we were given, and the one piece that we were given is 50 root 2. And the good news is we were given that was S. So S is 50 root 2. This side over here is also S, so this is also 50 root 2. And this is S times root 2. So S is 50 root 2. I'm taking that and I'm multiplying that by an additional root 2. Because remember, S times root 2. Root 2 times root 2 is just 2, so that becomes 50 times 2, which is 100. So again, that key right there is that shared side. That shared side we now know is 50 root 2. We want to be careful. 50 root 2 is representing S in the 45, 45, 90 triangle. but 50 root 2 is representing 2L in the 30, 60, 90 triangle. So I want to solve for L. So 2L is 50 root 2. We divide by 2, and L is 25 root 2. So I look around my triangle. This side is my L, so this side is the 25 root 2. This is L root 3. The L is 25 root 2, and I'm multiplying that by root 3. So that gives us 25 root 6. So when all is said and done, our first variable is our W. W again is this side over here, which is represented by the L pattern, which is 25 root 2. X is down here, the L root 3, which we found was 25 root 6. Y was that shared segment in between the two, which is 50 root 2. And Z is the hypotenuse of that 45, 45, 90 triangle, which is 100. All right, so our special rights, just a little bit harder, a little bit more complicated than the ones that we did yesterday. And we are done with that one.